Let's go ahead and take a look at one more problem from section 10.2 on independence. The problem says you work for an insurance company and are studying the relationship between types of crashes and the vehicles involved. As part of your study, you randomly select 3,027 vehicle crashes and organize the resulting data as shown in the contingency table. So at a significance level of 0.05, can you conclude that the type of crash depends on the type of vehicle? So here we have the summary of the data in this contingency table. So the vehicle, whether it's a car, pickup, or sport utility vehicle, is the column variable. So the categories of vehicle are organized into the columns of the table. And then likewise, the type of crash, whether it's a single vehicle or a multiple vehicle crash, are the rows of the table. So the type of crash is the row variable. So in part A, we're asked to identify the claim and to state the null and alternative hypotheses. Okay, so remember from our notes that the null hypothesis is always that the two variables in question are independent, and that the alternative hypothesis is that the two variables are not independent. Okay, so for the null hypothesis, we have that the type of crash and the type of vehicle are independent. Okay, so in other words, one does not affect the other, so the type of crash does not affect the type of vehicle involved. Okay, then likewise, the type of crash and the type of vehicle are dependent, okay, meaning that the type of crash will in some way influence the type of vehicle involved. Alright, and then the claim is represented by the alternative hypothesis. Right, because it says that, can you conclude that the type of crash depends on the type of vehicle, so it's very clearly the alternative hypothesis, that's the claim in the problem. Okay, part B says to find the degrees of freedom, find the critical value, and identify the rejection region. Okay, so you're going to go ahead and click continue. Okay, so the degrees of freedom is given by this formula here that we talked about in the previous video. Okay, so R represents the number of categories of the row variable, and then C represents the number of categories of the column variable. Okay, so we have the degrees of freedom. Okay, so since there are only two categories for the row variable, right, R is equal to 2, so we have 2 minus 1 in parentheses multiplied by, which is 3, because the number of categories of the column variable is 3, 1, 2, 3, so C is 3, so multiplied by 3 minus 1, also in parentheses. Okay, so it looks exactly like the previous problem was, so you end up with 1 times 2 is equal to 2, so there are 2 degrees of freedom. Okay, next we're going to find the critical value. So let's go on and head over to StatCrunch. So we're going to go to Stat, Calculators, chi-square. And remember, for getting the critical value using the chi-square calculator, select Standard. Alright, and since this is a right-tailed test, select greater than or equal to, and the degrees of freedom is 2. And remember, our significance level is 0.05, so that goes in this box here. So in other words, the area in the right tail is 0.05, and that's represented by the region shaded in red. That's our rejection region. Okay, and the critical value here is 5.991. which I believe is what it was in the previous problem. So we're going to put 5.991, so we're going to round our critical values to 3 decimal places, as indicated by the directions. Okay, let's go ahead and click continue. Okay, and this says which region below is the correct rejection region. So once again, referring to our notes, it's going to be the answer choice that looks like this. Okay, so our chi-square test statistic must be greater than the critical value to be in the rejection region. So that's going to be our answer choice. And let's click continue to go on to the next part of the question, which is part C. And part C says to calculate the test statistic. Okay, so remember, the test statistic always involves the data that you're given in the problem. Okay, so we got to go ahead and copy the table into StatCrunch. Just going to close this window. And you may or may not have data from the previous problem. So if you're doing multiple problems in the same spreadsheet in StatCrunch, let's go ahead and move over to a blank spot in our spreadsheet. All right, and click in the very top row, right where it says var 12, var 13, and so on. All right, and then paste that table. Okay, so this is the table from the problem. Okay, and to get the test statistic, we're going to go to stats, tables, contingency. So this is a contingency table that we have. All right, and whenever your data are in a contingency table, it means the data has already been summarized. So once again, tables, contingency, and then with summary is what we select. Okay, once again, you might have multiple columns of data. So for this particular problem, the columns that we're going to select are only for the column variable. So you're only selecting the columns that represent the categories of the column variable. So the categories of the column variable are car, pickup, sport, utility, which are the vehicle type. Okay, so we're going to select only those 3 columns. All right, and then the row labels are in the other column, in this case, which is type of crash. Okay, and then we don't need to select anything else. We're going to click compute. Okay, and what we're looking for is that test statistic, which will be at the very bottom of the output. So this is the output of this function. Okay, we're going to round that to 3 decimal places, so it looks like it's 123.49. $123.429. Okay, you can see that our test statistic is much larger than the critical value. Right, so whenever your test statistic is larger than the critical value, you're going to reject the null hypothesis. Okay, if not, like in the previous problem, if the test statistic is smaller than the critical value, you will fail to reject the null hypothesis. Okay, so in part D, decide to reject or fail to reject the null hypothesis, and then interpret the decision in the context of the original claim. So go ahead and click continue. Okay, so did we reject or fail to reject? So remember, when that test statistic is larger than your critical value, we always reject the null hypothesis. Right, so we reject the null hypothesis, and there is enough evidence to support the alternative hypothesis. Okay, and then the last part of the question says, how does this conclusion relate to the original claim? Just remember, the claim is given by this statement in the problem. Okay, rather it's a question. Okay, so at this level of significance, can we conclude that the type of crash depends on the type of vehicle? Okay, so remember, we rejected the null hypothesis in favor of the alternative hypothesis, And earlier in the problem, we said that the claim in the problem is represented by the alternative hypothesis. Okay, so in other words, we rejected the null hypothesis, saying that the type of crash and vehicle type were unrelated, meaning are independent. Okay, in favor of the alternative, which says that the type of crash and type of vehicle are related, meaning that they are dependent on each other. Okay, so in other words, we have support for the claim in the problem. So it looks like answer choice C is the best answer choice. So it says that this supports the claim that the types of crash and vehicle are related. Alright, and that completes question 5 from the homework in section 10.2. And good luck with the rest of this section. Thank you for watching.